This problem is testing our understanding of sequences. We're given sequence S, which is composed of n integers, where n is greater than 1, meaning that there is more than one integer in the sequence. We're also told the mean of the sequence is x. Something interesting and important to note is that if each element of S is multiplied by 3, the new mean remains the same. It remains x. And based off this information provided, we need to figure out which statement below must be true. So before we actually move into the statements, it's important to find a sequence that actually satisfies what was presented in the question. So if we had a sequence that was 1, 1, and 1, we'd have a mean of 1. N is also greater than 1 for the sequence. But if we multiply by 3 and produce this new sequence that would be 3, 3, and 3, we would have a new mean of 3 that does not stay the same as the original sequence. Therefore, it does not work for the question presented. But a sequence that would be 0, 0, 0. This also is a sequence that has n greater than 1. It has a mean of 0. And if we multiply by 3, we actually get the exact same sequence of 0, 0, 0, which has a mean of 0. So this sequence actually satisfies what was presented in the question and is what we're going to use moving forward. So we'll start with statement 1, where the mean is equal to 0. So if we look at the sequence that we just came across, the mean is equal to 0. But before we mark this one as true, we want to try out a couple other situations. So if we have a sequence that was minus 1, 0, and 1, we would see that this also has a mean of 0. It has n greater than 1. And if we multiply by 3 to produce a new sequence, which would be minus 3, 0, and 3, we would have the same mean of 0. So this sequence also works, and it proves that the mean remains 0, that x is equal to 0. So we'll mark this one as correct. And therefore, we can also eliminate answer choices B and C, because we know it's either has to be statement 1 only, or it could be statement 1 with a combination of 2, or all 3 statement choices. So now we'll move on to option 2, that the largest and smallest members of S have the same absolute value. So if we look at the sequence we just presented, this is true. The absolute value of minus 1 is equal to the absolute value of 1, which remains 1. And if we look over here after the one that's multiplied by 3, and we take the absolute value of minus 3 and compare it with the absolute value of 3, they are equivalent. And these two are also the smallest and the largest member of the sequence. So far it looks like it's true, but we should try and find an example that disproves it. And we can if we have minus 2, 1, and 1. This has a mean of 0, but its absolute value of its smallest number, which is minus 2, is 2. And if we compare that to its largest number, which is 1, we see that they don't have the same absolute value. And just to confirm, we'll note that this sequence has n is greater than 1. And if we multiply it by 3, which will lead to a sequence that contains the elements minus 6, 3, and 3, that the mean remains 0. So this sequence actually satisfies the question and shows that the absolute value of the smallest member and the largest member does not necessarily have to be equivalent to maintain the mean equal to 0. So we'll cross off statement 2, and therefore we can get rid of answer choice D. So now, before we already know that based off of this, by proving that statement 2 is incorrect, that answer choice E is also incorrect, it's still best if we have time to disprove statement number 3. So statement number 3 says that sequence S contains both positive and negative numbers. And this one's very easy to disprove because we already have a sequence that is 0, 0, 0, and has a mean of 0, and when multiplied by 3 still has a mean of 0, so we can disprove statement 3. Therefore, we know that statement 1 is the only correct statement and that answer choice A is correct.